Welcome, students, to section 8.2. Let's see what we're getting ourselves into today. All right, let's see. We are going to do the graph of the other four trig functions. All right, and the key to doing the graph of the secant and cosecant, which I'll do first, is to know very carefully how to graph the sine and cosine. So that's what it's all about. So what we're going to do to begin with here is we're going to just fill in this table right here. Now you can refer to all this stuff from the unit circle. So the sine of 0 is 0. The sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And then back through 1 period to get to 0. If you go backwards with this, it'll cycle through these points. So sine of negative pi over 2 is negative 1. Then back to 0, then to 1, and then to 0. Refer to the unit circle if you need to on that. Again, all I'm doing is just getting the y value of each point. Okay, the next thing you got to know is the cosecant of an angle theta is just 1 over the sine of an angle theta. Okay, so what we're going to do is we're just going to do the reciprocal of all these numbers. And you got to be kind of careful. Notice that when you do the reciprocal of 0, what do you get? Yeah, you get something that's undefined, so you're going to end up with having what we call a vertical asymptote. So everywhere the sine is 0, the cosecant is going to be undefined. Okay, and then the rest of these, well, if you do the reciprocal of 1, you still get 1. If you do the reciprocal of negative 1 over 1, turn that upside down, you still get negative 1, and so forth. So that kind of gives you the key points that you would get, and all that's coming from the unit circle. So let's see, what I'll have you do is we're going to go ahead and get our graph set up. So we want to just increment the x-axis by pi over 2. So you want to go ahead and get everything set up there. And we're going to take this through 2 periods. That's what I decided to do in going over this. And then the y value will probably need to go up bigger than 1, just so you can kind of see what's going on. And then I might show you a couple of things on the graphing calculator to help you understand what happens around the asymptotes. So I'm going to recommend that we go 1, 2, 3, let's go up to 4, and then let's go down to negative 4 like that. Okay, now what we're going to do is we're going to graph both of these things. So to begin with, I'm going to just graph the sine. Okay, you want to get to a point where you have the sine memorized. So sine of 0, 0, you have 0, 0. Then you hit your max, back to the x-axis, to your min, and so forth. So you want to be able to just quickly be able to graph those points on the sine of x. So this is going to be my graph in red of y equals sine x. Okay, and then I'll have you just, kind of dash that in. That's is an important part of learning how to do the cosecant graph, is to relate it to the graph of the sine. All right, so that'll take us through that piece right there then. Okay, the next thing that you want to do is you want to put in your vertical asymptotes. So what I'm going to do on this is let's just go to every place where you're undefined. Okay, you want to put a vertical asymptote. So just draw a dashed line going through those. We also call those the midpoints, that would kind of go through the midline of your sine. So those are an important part of the graph. The y-axis also is going to act as an asymptote on this, so you want to get that done. Okay, now let me kind of show you what happens on this. We're going to plot maybe a couple of other points on here. And let's see, I'll pick like maybe a different color here, like orange or something. Okay, well, at negative 3 pi over 2, the value of the cosecant is 1. So it's right there. At negative pi over 2, you have a negative 1, and so forth. So you just plot those points, and then you're going to sketch the shape, and I'll explain kind of what happens on this. So what you're going to find is it's going to kind of, in this region, it's going to go up. You always, when you get close to a vertical asymptote, your graph either goes to infinity or negative infinity. In that case, it goes towards infinity as you get closer. I'll explain why that is in just a minute. And then down here on this minimum, you're going to approach negative infinity as you get closer and closer to that vertical asymptote. So really, once you get the sign put together, then it's real easy to draw a pretty accurate sketch of the cosecant. Okay, so let me explain a couple of things on this. I'm going to get my calculator set up here. Okay, so I'm going to explain these asymptotes here. So just kind of show you what happens on this. Really, what's happening is you're really doing the reciprocal of a number close to 0 on here. So if I was to go through and do this, I'm going to, just for simplicity, I'm just going to put this in degree mode to begin with and just kind of show you how this works out. So if I was doing the cosecant of a number real close to 0, let me show you what happens on this. So the idea, you know, if I take 1 divided by 0, I just get something that's undefined. That's why the cosecant's graph is going to be undefined. But the other thing I want to show you is if I was barely to the right, like if I was at just 0.1, if I take 1 divided by 0.1, that just means I'm just barely to the right of x equals 0. Well, I get 10, so that value is going to get bigger. And then if I close in on that, if I take 1 divided by a number even closer to 0, like say 0.001, then it goes to 1,000 and so forth. So what you're going to find is if you take 1 divided by a number closer and closer and closer to 0, it gets bigger. So see, when I do that, that's scientific notation. That is saying, you know, 1 times 10 to the 14th power, so that's just a 1 with the decimal moved over to the right 14 places, so you're starting to get, you know, into the trillions and stuff, all right? So that's what happens on that. One other thing I want to show you on the calculator, too, is this. So it'll happen very close to these things. So if I was to go to, like, 180 degrees, and if I did the cosecant, see, if I do the cosine of 1, and I have to do this like this, I have to go 1 divided by the sine of, say, 179 degrees. That's how I put in the cosecant. Well, I'm getting a real big number. So the closer you get to that value of 180 or pi, the higher that graph goes. And if I go to the right of that, like if I did 1 over the sine of, say, 181 degrees, okay, then it's starting to get a real small number, so that's why it's going to negative infinity. So I think it's real helpful to understand the mathematics behind what's working, what's happening at a vertical asymptote. And in reality, what you're doing is you're just doing 1 divided by a number very close to 0 that's either negative or positive. That's why the graph either goes to infinity or negative infinity. Okay, so that's how that goes. I think while I've got the calculator out, I'm just going to show you kind of, if you want to do this with me, you can. I haven't done a lot of the stuff on the graphing calculator yet. But what will happen on this, if you put these two graphs in, this is worth doing and kind of worth learning on your graphing calculator. So if I put in y equals sine x into y1, I put cosecant in by doing 1 divided by sine of x. And then I'm going to go ahead and just do this in, I'm going to change the mode to radians. And then I'm going to do a window. Okay, so the window goes like this. You just want to go from, start at negative 2 pi. Okay, like that. So you get that put in for your minimum. We're going to go all the way up to 2 pi on the x-axis, like we did in our chart. And then we're going to scale that by pi over 2. So I just put pi divided by 2, just changes those things to decimals. And then y, we're going to go like, let's go actually like maybe negative 5 to 5 by a scale of 1. So if you get all that put in, and you can pause if you need to see that window, or I can usually slide these viewing windows over here a little bit. Now, if you go ahead and graph, then you should see what we just did. You'll see the sine coming out in blue, and then you'll see the cosecant coming out like that. The asymptotes don't show up on a typical TI-84 calculator, but you can tell where they are. Okay, so it's worth knowing how to check some things that you're doing on the calculator as well, but you definitely have to know how to do these things by hand. Okay, so a couple of observations on this. So notice that in this graph, we don't have a minimum y value. Okay, the cosecant gets lower forever. So we don't have a minimum. We also do not have a maximum. So the range would actually be everything except there. Okay, you've got a y value for everything except -1 to 1. So the way you would say your range for a cosecant, there's two ways. You could say set of y such that y is less than or equal to -1, or y is greater than or equal to 1. Or if you wanted to do this in interval notation, you would say -infinity to -1 with a bracket to include -1, and then union 1 to infinity. Okay, the period is 2 pi. All right, and it's going to go like this. If you look at the period is just going to end up being from there to there. You kind of define a cosecant by 3 asymptotes, 1, 2, 3, and then the shape that kind of goes up and the shape that goes down. They look like parabolas. They're not parabolas, but they have that kind of look to it. Okay, all right. The cosecant's undefined. Now what we're going to do on this, just kind of look at your chart, and let's go back and look at all the places that we were undefined. And then, of the amplitude, we don't have one. And the reason we don't have an amplitude is because there's no max or min. Your graph's never going to have an amplitude unless it has a maximum and a minimum, and that occurs periodically. Okay, so let's write down the cosecant. We were undefined at -2 pi, pi, 0. I'm going to write that as 0 pi, pi, and 2 pi. And I'll even write that as 1 pi and -1 pi. Okay, like that. So what we're doing is we're looking kind of for a pattern. When we write the domain of the cosecant, we're telling what x can be. Well, there's all these things that x can't be, and this graph goes on forever. So these things go on forever. So when you do your domain, you actually have to kind of write this in a formula. So let me show you what you do. So you say set of x, that's what a domain always is. And then what I want you to notice is you always have pi, but you always have a whole number in front, or an integer, okay? The numbers 0, 1, 2, going on forever, and then of course your negatives, those are integers. We call that integers. So we have to write this in a formula. So we say the set of x such that x is equal to, I usually say k pi, and then I say, and k is any integer. And that's the way you have to write this, is like that. You have to write it as in a formula, and then you have to say that's not equal to. So we'd say k is any integer. So you got to think about that a little bit. You're just saying that x is everything except where there's an asymptote. The asymptotes occur at k pi. 0 pi, 1 pi, 2 pi, -1 pi, -2 pi, and so forth, see. So that the number that changes is the number in front of pi, okay? Same thing happens on your asymptotes. Your vertical asymptotes occur at -2 pi, -1 pi, 0 pi, 1 pi, 2 pi, and of course that goes on forever. You have an infinite number of asymptotes. So the equation of your vertical asymptotes are x equals k pi, where k is an integer. Now, if you want to learn symbolism, this little kind of z, that kind of stands for real numbers. So if you want to abbreviate that, you'll see me write this like this quite a bit. So you just say the equations are x equals k pi, and k is a member of the integers. Okay, so that's the symbol for integers, and then this just means a member of the set, or an element of the set. That's the Greek letter sigma is what we do. So you have to write that domain and those asymptotes with a formula because there's an infinite number of those, okay? One other thing I want to mention on this just for a minute here is you basically have a formula that you can use also. I always recommend to students just write out where the asymptotes are and then see if you can see a pattern that allows you to write a formula. If you have trouble seeing the pattern, you can do this. So this formula goes like this. You could just say, for your asymptotes, you could say it's the set of x. X is the first positive asymptote. So you could either use 1 pi, you could even use just 0 if you wanted to. I usually just say find an asymptote, either 0 or positive, and then you say plus 1/2 the period, the period is 2 pi times k, and then you say k is an integer. So notice you'd get the same answer on this because you would end up getting set of k. You would just get x equals 0 plus pi k, so you would get pi k. And it doesn't matter what order you do that in, the pi k, so you could write it like that. So that formula, what you can always do is just do x is an asymptote. You can pick any asymptote you want to, really. Then it's half the period k, where k is an integer. The reason it's half the period is because I want you to notice that halfway in the middle is an asymptote. Remember, you have 1, 2, 3 asymptotes for every period, and one of those asymptotes occurs halfway in the middle. So that's why you would say pick the first asymptote, half the period would be where the next asymptote is. Okay, so those are things you got to think about a little bit. So that would be the beginning kind of a cosecant graph, and then we'll move on and do kind of a similar thing for the secant. Okay. All right, so I'm going to move on to the next thing, and we're going to do the same thing, except we're going to work a little bit now with the graph of the secant, okay, which is very similar. So what we'll do is we'll start off by doing the filling out the values for the cosine. Remember, the cosine is just the x value on a unit circle, so we should be able to quickly fill this out. I'll start here. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1, and so forth. Okay, when you go backwards with this, it's going to go -1, 0, 1, 0, like that. So those are your key points that we've learned on the cosine graph. Okay, now what do you do to find a secant? Well, again, the secant of an angle theta is just the reciprocal of the cosine. So we're just going to do the reciprocal of all these values. Notice on here that if you do, I think I got off track here a little bit somehow, so I need to fix what I was doing. I was doing that real fast, so I apologize for that. If you go to -2 pi, when you go to -pi over 2, you have 0 as your cosine. Then when you go to -pi, you're at -1. And then I go to -3 pi over 2, I'm back to 0, and then finally back to 1. Okay? So, and notice you'll always alternate between a 0. That's how I caught my mistake. So I'm going to do the reciprocal, and notice that you will be undefined at these locations, and that's where you're going to get vertical asymptotes. So I'm just going to put undefined every place where the cosine is 0. That's what we'd expect to happen. And then the rest of this is reciprocal. So if you do the reciprocal of 1, turn that upside down, you get 1. If you do the reciprocal of -1 over 1, turn that upside down, you still get -1, and so forth. So you can fill those out in your head. So what we're going to do is the same thing. We're going to just create our graph. So let's get it set up. We've got pi over 2, pi, 3 pi over 2, and then to 2 pi. We're going to graph this through 2 periods. And then we have -pi over 2, -pi, -3 pi over 2, and then -2 pi. Right? And then we'll go like we did on the last problem. We'll just go up to about 4, and then down to -4, like that. And then we're going to do just the same kind of graph. Okay, let's start by graphing the cosine. So the cosine, I always remember, starts at its maximum. You have a point 0, 1. Then it alternates through these points. X-intercept, minimum, x-intercept, maximum. And you can kind of cycle through that real easily and very quickly get those points done. So that will be the graph of y equals cosine x. Okay, you want to just do that in a dashed graph, and then I'll label that as y equals cosine x. Okay, so that's how we start. When you graph a secant, really what you're going to do for the most part is graph the corresponding cosine, get your asymptotes, and then take it from there. Okay, so the asymptotes occur where you have midpoints. Okay, so it would be right through these points where you're on. And don't think of it necessarily as x-intercepts. Think of it as midpoints. That's a better thought process, I think, because of when you have a graph that has a vertical translation. Okay, so we're going to go like that. That'll give us our asymptotes. And then the rest of it you sketch. Okay, so it's exactly the same concept as what you would have on the cosecant. So notice that at negative 2 pi, the cosecant has a value of 1, so I have a dot there, but then it's going to loop up and approach the asymptote like that. At negative pi, the cosecant is negative 1, but again, it's going to go down and approach the vertical asymptotes going to negative infinity. And then on the maximum, it goes up like that. And then when you're on the minimum, it goes down like that. So it's a very similar graph. It really could be thought of as a phase shift of the one we just did. That's what it is. Okay, same observations kind of apply to this graph. So let's kind of answer these. Okay, what do we know about the minimum y value? Okay, we don't have one. There's no minimum. Maximum, there's no maximum. There is on a cosine, but there isn't on a secant. So we have none there. Okay, the range would be everything except between negative 1 and 1. So the cosecant graph, it connects with the cosines max and minimums, but it's not going to have any values between negative 1 and 1. So like we did before, what you can do is you could either say set of y with y less than or equal to negative 1, or y being greater than or equal to 1. Or you could do this in interval notation and just say negative infinity to negative 1, bracket, union, bracket, 1 to infinity. Okay, the period is still 2 pi. And I usually kind of like to look at this like this. It doesn't really matter where you start that period, but if you went like from here over to there, you could think of the same thing. You have an asymptote in the middle, and then a final asymptote. You have the shape that goes upward and then the shape that goes downward. So the distance between negative pi over 2 and 3 pi over 2, that's still 2 pi. If you want to find the distance between two numbers, you subtract them. So notice if I did that, I'd have 3 pi over 2 plus pi over 2. Well, that's 4 pi over 2, so that's still 2 pi. So it's got the same period that the cosecant had. Okay, the amplitude is none. Okay, we don't have a max or a min, so you don't have an amplitude when you're dealing with a secant. Okay, let's write down where it's undefined. So this time we're undefined at negative 3 pi over 2, negative 1 pi over 2, 1 pi over 2, 3 pi over 2, and again, you're going to be undefined forever at these locations. What you got to do is just see the pattern. So when you write the domain, you have to write a formula that does that. So the way you have to write the domain is again, you have to say set of x, and then you got to tell me what it's not equal to. Well, there's a pattern. You always have pi over 2, but the number in front is what's changing. So let me ask you this question. What would you predict comes after 3 pi over 2? You have 1 pi, 3 pi, what's next? 5 pi over 2, 7 pi over 2, so what am I doing? Yeah, I've got odd integers. Okay, so I really have odd integers, but I always have pi over 2. So you would say x is not equal to k pi over 2, and then you would have to say k is an odd integer. So that's how you get that then. Then the vertical asymptotes is exactly the same concept. So if you list where the vertical asymptotes are, well, you got negative 3 pi over 2, negative 1 pi over 2, 1 pi over 2, 3 pi over 2. You can go as far with this as you want to. Then it would be 5 pi over 2, 7 pi over 2. It would be odd pi over 2. All right. So what you would say is the equations of the vertical asymptotes are x equals k pi over 2. And then again, you would have to say k is an odd integer. You have to say it's an odd integer or you're not, you have to tell me what k is, in other words. Okay. So that's one thing that you do with these graphs is you have to identify the asymptotes. I recommend writing out the asymptotes on your graph and seeing if you see a pattern. Most of the time you will, and then just writing your formula based on that. If you have trouble seeing the pattern, same thing would apply. So let's do this like this. Now you can get a different answer. So you could say set of x. The first positive asymptote I had, I think, was pi over 2. So I could say pi over 2 plus 1/2 the period. The period's 2 pi times k, and k is an integer. So that would cross out. So you could also say x is equal to pi over 2 plus pi k, where k is, in this case, it's an integer. It's not an odd integer. So if you follow this formula, that will give you an acceptable answer to the problem. So what I say to do is to try to build the formula yourself. And if you struggle with that, just go to this formula and understand that formula to remember it. So you always have a asymptote halfway in the middle of the period. That's why the next asymptote's always 1/2 of the period. If you understand that, and you'll remember that. Okay, so that'll take us through the basic graphs of the secant and cosecant and just the basic ideas. Now we're going to move on to doing some transformations on the next page. Okay, so to begin with, whenever you're graphing secants and cosecants with transformations, this is what I recommend that you do. The first thing that you want to do is just graph the sine or cosine. So if it's a secant, graph the cosine. If it's cosecant, graph the sine. So in a sense, you're not learning anything new. Then what you do is you basically find the vertical asymptotes. Those vertical asymptotes will always occur at midpoints. So if you kind of think about where your midline is, the asymptotes go through those midpoints. Okay, and then sketch the asymptotes, then sketch the final graph. So you're going to do a sketch after you get the sine or cosine done. It's simple. Okay, and then check at least 2 points. I always recommend you do that because you have the ability to tell you're right, and it'll help you understand the graphing process a whole lot better if you take the time to just check at least 2 points. You can check all 5, and if they're all 5 right, then you've got 1 period through that graph then. Okay, so going down here, we're going to look at, this is a cosecant. So if it's cosecant, what do? Sine or cosine? Yeah, we're going to do sine. So what we're going to really do is we're going to totally focus on the sine of this. Now you have to put this in a factored form because you have a phase shift. So what we're going to do is we're going to pull that 2 out, and then we'll have a set of parentheses like that. We learned how to do this in a previous section. So that would be 2x, because 2 times x is 2x. Now to figure out what goes here, you always do the same thing. You just take the 3 pi over 2, and you divide it by the number you factored out. So you're going to divide that by 2. So that would be 3 pi over 2 times 1/2. So that would give, when you go straight across, that's going to give 3 pi over 4. Okay, it's always a good idea to check with the distributive property. So you've got 2 times x is 2x. And then if you do this, so you could just go 2 times 3 pi over 4, reduce the fraction to get 3 pi over 2. So if you factor something, check it. Why? Because if you don't and you mess up, then you're wasting time. Okay? You want to get everything right. Everything's based on your ability to correctly factor that. Okay, so the factored form we would have for this cosecant is we'd have 2 cosecant of 2 parentheses x plus 3 pi over 4. But what we're going to focus on is we're going to focus on graphing the sine of this. And then once we get that graphed, then it should be real easy to sketch that cosecant. Okay, so that's what you do. If it needs to be in a factored form, put it in a factored form. Okay, the formula for the period is the same. It's 2 pi over b. So what we're going to do is that. Now the value of b is the 2. So what we're going to do is we're going to do 2 pi over 2. And that the 2's cross out, giving you pi. So that means the period is going to be changed from 2 pi to pi. Okay. The amplitude of the cosecant is none. However, the amplitude of the sine in this problem is going to be 2. Okay, so that's pretty important when we do the graph, is to understand our sine wave has an amplitude of 2, but the cosecant never has an amplitude. Okay, the phase shift. Which number is the phase shift? And just totally look at this part right here. Okay, so that's the A, that's the amplitude. The 2 gives you the period, so what's the phase shift? Right, it's that number. So that phase shift, it's a plus, so which way? That's going to be to the left. Okay, and we would say negative 3 pi over 4. I don't care if you say negative or positive. That doesn't really matter to me. It's just you need to know what that number is and which direction. Okay, but if it's left, I think typically you like to write that as a negative phase shift. Okay, how do you find the increment? We've already learned that. Period divided by 4. Okay, so take the period, which is pi, and divide that by 4. Okay, and that will tell you how to set up your x-axis. So what I recommend that you do on this then is, it's always a good idea to start at 0. Okay, so, and then just start counting by pi over 4. So you'd have pi over 4, then you'd have 2 pi over 4, which reduces to pi over 2. Then you go to 3 pi over 4. Then you go to 4 pi over 4, which reduces to pi. Okay, now if you count to 5, see, we've made it through the period. See, the period's pi, so 1, 2, 3, 4, 5 should get you through 5 key points. Okay, now you can go further on that if you want to, or you can go backwards. And I'm going to go backwards on this and just go negative pi over 4, and then I'm going to go negative pi over 2, and then I'm going to go negative 3 pi over 4 like that. Because what I generally like you to do is when you graph, most of the time I'm going to have you graph one period, and if there's a phase shift, I like you to start at that phase shift. That's the reason I'm counting back to negative 3 pi over 4, so I can begin my graph there then. Okay? Okay, so I'm going to take a screenshot of this thing right here, and then we'll move to the next page because I need to refer to this as we go. Okay, so let's move to the next page. Always pause if you need to pause and process or get things written down. Okay, so what I'm going to do with this then is we're going to focus on graphing this. And let's do our increment. Our increment's pi over 4, so let's count out like pi over 4, pi over 2, 3 pi over 4, and that's probably good enough because we're just going to do one period. Okay, then go backwards. We're going to do negative pi over 4, negative pi over 2, and then negative 3 pi over 4. Since our phase shift is negative 3 pi over 4, that's why I'm going to the left on that. Okay, all right, we have an amplitude on this of 2. We don't have any up-down, so there's no up-down stuff. So that means that really on our graph, we need to go to 2, and then we probably want to go beyond because we're graphing a cosecant. So let's go up to like 4, and then maybe down to negative 4 like that. Okay. Now, what we do is we do this. Now, remember, one of the things I've been trying to show you how to do is this. Remember, a sine starts at 0, 0. Then it goes to its max. Then it would go like that. Okay, if you had an amplitude of 2, a basic sine would go like that, like that, like that. However, we're phase shifting. So just start this cycle here. So what I do is put the first point there, then the second point there, goes to the max, then there, and so forth. Okay, and then one more point would take you back there. So what I'm saying on this then is, just think about where your basic points are and then phase shift them. And that'll be good enough. That's 1, 2, 3, 4, 5 key points. So that will be our basic graph of the sine. So you want to label then that is the graph of y equals 2 sine 2 times x plus 3 pi over 4. Okay, so that's what we have computed so far. Now see, once you've done that now, then it's easy to get the graph of the cosecant. So what you do is identify the midpoints. The midpoints occur here, here, and there. Okay, there's 3 midpoints through this period, so let's draw our asymptotes. So just take a vertical line that goes through these midpoints, and then we'll be ready to sketch our final graph. And then we're going to I'll probably go through and check a couple of points and show you how to do that on some of these problems. So that's it. And then the next thing is just let's graph the final product. So again, you always connect with the sign, but then in this, when you have a maximum, the graph's going to point upwards and head to infinity. If you have a minimum, it's going to connect with the graph, this time having a y value of -2, and goes like that. So that's the graph. You could go to more periods if you want to. It's a piece of cake. There's nothing to it. So generally, I want you to do 1 period. Okay? All right, so next thing is we're going to look at the equation of the vertical asymptotes. What I always recommend is you write down where they are and see if you see a pattern. So we have -3 pi over 4, -1 pi over 4, 1 pi over 4. Now, if you count it out further, the next one would be at 3 pi over 4. Now, let me ask you this question. What do you think would happen after the 3? Right, 5 pi over 4, then what? 7 pi over 4. See, you can predict the pattern. So what you see is, notice you always have a pi over 4, but what changes is the number in front. So what kind of numbers are those? Yeah, those are odd integers. So that would be a part of how you write this. So here's what you do then. You just say x is equal to k pi over 4, and then you say k is an odd integer. Okay, so that's it. Those are the equations of your vertical asymptotes. All right. So that's how that would go then. Okay, now just at the side of the paper here, before I go to the next problem, you can write this down, or you can just watch this if you want to. But what I want to show you is how simple it is to just check a couple of points. And what I'm going to do is I'm going to start at the beginning on here. So I'm just going to, for checking, I'm going to choose x equals -3 pi over 4. Okay, now I'm going to check that on the sign because it's the sign graph that matters. Okay, so don't check it in the cosecant necessarily if you want to, but you could. Actually, let's go ahead and check it in the cosecant. Why not? So what we have is we have y equals 2 cosecant of 2 times, and then plug in the -3 pi over 4 plus 3 pi over 4. Okay, so again, I'm just plugging that into the equation. And the reason I do this point is because this is where an asymptote is. So you would end up with y equals 2 cosecant. Stop that. So it'd be 2 cosecant of 0. Okay, well, the cosecant of 0 is undefined, so we would expect to get an asymptote there. Look at your unit circle if you have to. Okay, and then you could do the next point the same way. I'll just go ahead and check one more point, and then we'll see if that's right then. Okay, all right. So let me just do this over here. So let's check like x equals -pi over 2. Oh, come on, OneNote, stop your crap. God, this program drives me crazy. Okay, so let me do it down here. All right, so we got, hold on. Okay, so I went ahead and just kind of wrote down the checking on this. And you can write this down or look at this if you want to. So if you plug in -pi over 2 into the function, you would really, after you do this arithmetic, you would end up with 2 cosecant of pi over 2. And the cosecant of pi over 2 is 1, so 2 times 1 is 2, and that matches with the y value. So I basically showed this. I showed that at -3 pi over 2, you're undefined, or -3 pi over 4, you're undefined. Then I showed at -pi over 2, you're equal to 2. So that's the idea. Okay, let's move on and let me do a secant example. And the key thing on this one is we're going to work with a cosine since it's a secant. This needs to be factored, so you need to pull the 2/3 out. So let's go ahead and do that. So we would have y equals 1/2 secant, bracket, 2/3, then parenthesis, still got the plus 2. Okay, so you'd have x there. Now what goes here is you always do this. You always take the pi, this number here, and divide that by the number you factor out. So that would be pi times 3/2. So that would end up being minus 3 pi over 2. Okay, and it's a real good idea to check by distributing. Just in your mind with practice, it's pretty easy to check that. See, that's 2/3 x. And then this is 6 pi over 6. 6 pi over 6 is pi, so it checks out. Okay, so the factored form we're going to work with is this, 1/2 secant 2/3 x minus 3 pi over 2 plus 2. And then we're going to graph the cosine. So our focus is going to be on doing the cosine and seeing where that leads us. Okay. All right, so we're going to just do kind of the basic things we've been doing. So how do you find the period of a cosine? 2 pi over b, exactly. Okay, so in this case, b is 2/3. Okay, so what we're going to do is we have 2 pi divided by 2/3. So that is 2 pi times 3/2. 2's divide out, so you would have a period of 3 pi. Okay, so in this case, the period is larger than the original 2 pi. Okay, the amplitude of a secant is none. However, the amplitude of the corresponding cosine is 1/2. Okay, so on this cosine, we're going to have 1/2, and that we need to look at that when we graph that. Okay, the phase shift is this number here, so that's going to be 3 pi over 2. Is it left or right? Okay, minus tells us to the right. How do you find the increment? Period over 4. So the period's 3 pi. Divide by 4. Okay, so we got all the key stuff here that we need. Okay, so what we want to do here then is we want to go ahead and let's just get the x values. It's good to start with 0 and then just start counting by 3 pi over 4. When we get to the fifth one, we should be at 3 pi. So it's kind of like a self-check. So it's 3 pi over 4. Then it would be 6 pi over 4. So I'm counting by the numerator, which would be 3 pi over 2. Then we would go to 9 pi over 4. Then we would go to 12 pi over 4. But 12 pi over 4 is 3 pi. Okay? And what we want to do is we want to start at the phase shift. See, so if we start at this phase shift at 3 pi over 2, then we probably want to move out either to the left or to the right of that. So I'm going to count a little bit further. So I'm going to go 3 pi over 2, then 9 pi, 12 pi, 15 pi over 4. I'm going to go out there. And then I'm going to go to 18 pi over 4, which reduces down to 9 pi over 2. Okay, so again, I'm just counting by that numerator, so I'm going 3 pi, 6 pi, 9 pi, 12 pi, 15 pi, 18 pi, and then reducing. Okay, so what we're going to do then on the next page is we're going to go ahead, I'll slide down just a little bit here so we can go ahead and get our graph set up then. Okay, so we're going to be doing this cosine. And I didn't write that in the factored form. So at the side, I'm just going to write out 1/2 cosine of 2/3 x minus 3 pi over 2 plus 2, just for reference. Okay, and then let's go ahead and get this set up. So we're going to just write these increments. So we're going to go to 3 pi over 4. 3 pi over 2, 9 pi over 4, 3 pi, and then 15 pi over 4, and then all the way out to 9 pi over 2. Now you could go backwards with this also if you wanted to, and it might make it a little bit simpler, but I'm going to start at the phase shift, and let's go ahead and do this one by 2 periods. So I'm going to go negative 3 pi over 4, negative 3 pi over 2, and then maybe out one more like that. Okay, so we got that, and then you want to do your y values. Well, one thing we have on here is the amplitude of the cosine's a half, but then we're going up 2. So actually, the maximum on this would be, if you forget about the 2, you would have a max of 1/2, and then you'd have a min of negative 1/2. But then when you move that up 2, you would end up going to 2.5, and you would end up going to, that would be 1.5 for your minimum. Okay, so let's go ahead and make this go up maybe to, let's see, let's do 2, 3, maybe 4 like that. It's probably good enough. Don't probably need to do anything on the y-axis. But I'm going to go ahead and just put negative 4 there. And then I'm just going to put little halfway marks in there. Okay, then we're ready to get this put together. Okay, so remember, you want to get to a point where you can do this in 1 or 2 steps. You can get down to 1 step if you're pretty aware of this. So let's just look at a cosine. If you were doing a basic cosine, it would have, and I'm just going to lightly put in these values right here. Okay, so just kind of slightly sketch. A cosine starts at 0, 1. Then it would go through these key points kind of like that. Okay, however, what we're doing is we're going to phase shift. So we're going to start at 3 pi over 2. So my first point is going to 3 pi over 2, and it would be here. However, think about what that would be. That maximum moves to 2.5. Okay, so that point right there is going to go all the way up to 2.5 like that. Okay, that next point is going to, after you're there, then you would be here. You'd be down from this point to that point, but that's also going to move up too, so that point's going to go there. Okay, then the next point would be negative 1/2 moved up 2, so that would be at 1.5. And then from there, you can see the pattern and get that put on there. If you have to do that in 2 steps, do that in 2 steps. So what I'm really doing on this is I'm phase shifting, then I'm multiplying that y value by 1/2 and adding 2. Okay, so if you need to do this, you can. The y value of 1, 1/2 plus 2 takes you to 2.5. The y value of 0 on a basic cosine would take you to 2. The y value of negative 1 on a basic cosine would take you to 1.5. That's what I'm doing. You can do that in your head, or you can write it out if you need to. Okay, so that would take us through that. Now I'm just going to kind of work backwards on this. So if you go backwards, that would be at 2. This would be at 1.5. That would be at 2. That would be at 2.5. And that gets us through a couple of cycles. So let's go ahead and just sketch that in. And then that would be the graph of this cosine function right there. Okay, that's the big work of the problem. Okay, next thing is locate your midpoints. So your midpoints are here. That's where your asymptotes are. Okay, they're always at the midpoints. So then let's draw your asymptotes. So that first asymptote would go through negative 3 pi over 4. The second one would go through 3 pi over 4. Then the third one would go through 9 pi over 4. And then the next one would go through 15 pi over 4. So it might be a little bit challenging on this one to find a pattern. So we might just on the asymptotes on this use that formula. Okay. All right. So what we do from there is we just sketch the rest. So when we do this, okay, just sketch the period. The maximum goes like that. The minimum goes down to negative infinity. Okay, the maximum goes like that, and so forth. So this is actually taking us through 2 periods. Okay. All right, so let's look at the asymptotes. So a good thing to do to start with is just, write down what we found. We found negative 3 pi over 4, positive 3 pi over 4, then we found 9 pi over 4, then we found 15 pi over 4. Okay, well, notice these things are going up by 6, so the next one would be 21 pi over 4, and so forth. Okay, it's a little hard to see that pattern on that. So what I would recommend, there's a couple of ways you could do this. I'd probably just be inclined on these to just do the formula. So the formula goes like this. We just say x equals, and pick an asymptote. I usually say pick the first positive. So the first positive asymptote's 3 pi over 4. Then you say plus 1/2 the period. The period on this was 3 pi. Okay, times k, and then k is an integer. Okay, so what you could do is write x equals 3 pi over 4 plus 3 pi over 2. And then you just say k is an integer. I'm going to use that symbolism like that. And that would be a real easy way to write that, is like that. Okay, otherwise you could find a pattern and kind of write a formula in a different way. But to me, it's just as easy to do that. Okay. All right, so that'll take care of that. And one thing I want to show you on this too is this is the first asymptote. So if you did 3 pi over 4 and added 3 pi over 2 to it, let me show you what would happen. You'd get a common denominator. So you would get 3 pi over 4 plus 6 pi over 4, which is 9 pi over 4. So that gives you the next asymptote. So you can check your equation of asymptotes too. Okay, that one I'm not going to probably bother checking 2 points. You can do that if you want to. So I'm going to go ahead and put you to work on doing, I think, 2 examples, and then that'll wrap up what we want to do in this part. I'm going to have you do a cosecant, and then I'm going to, I guess 1. I'm just going to have you do 1. I guess the theory is if you can do 1, you can do several. Okay, so let's go ahead. I'm going to pause. I'll work it out while you're working it out. And then we'll see, come back and check, and then I'll close off part 1. Okay, so let's check and see how you did here. I didn't do the graph. I just wanted to kind of have you check what you did on this page, and then we'll do the graph together in case you have a little bit of trouble getting that sine graph put together. All right, so what you should have, your factored form should be this, negative 2 cosecant pi x plus 1/4 minus 3. The period's 2 pi over b. Of course, b is pi in this problem. The pi's cancel out, leaving 2. A lot of times students kind of freak out when there's not a pi in the period. That's a good thing, okay? So it's okay. Just do whatever the formula tells you. Amplitude, the cosecant has no amplitude. However, the sine would have an amplitude of 2, and that's important in the graphing. The phase shift is, after the factored form, would be negative 1/4 to the left. The increment is the period 2 over 4, which reduces to 1/2. So you want to make sure all this stuff's correct. Then you want to start counting out the increment. You always want to start with 0. So I just did like this. 0, 1/2, 2/2, 3/2, 4/2, reduce the fraction. So what I'm going to do on my graph is just do these 5 key points. I'm going to start with the phase shift and do that then. All right, so on the next page, pause if you need to get anything corrected. I'm going to go on to the next page, and then we'll put together a graph, okay? All right, so I got everything set up. So this is how you should have set up your x and y axis. Now, what we're going to do is we're doing a sine, but we're going to start with that phase shift. So, whoa, hold on just 1 second here. I want to check one little thing here. Okay, so what we encounter on this is, notice the phase shift is not on one of the increments. I've been trying to avoid that, but it's okay because 1/4 is just halfway in the middle here. So what I'm going to do is just kind of subdivide these into halves, and you're going to end up having your kind of key points in increments halfway in between. So we're going to start right there at negative 1/4, okay? So the way I look at this is like this, and again, just kind of watch this carefully. We're used to the sign of 0 being 0. Well, that point is going to phase shift over here, okay, like that. So what's going to happen is this. I want to show you kind of how you can put this together if you're struggling a little bit with your graph. We're starting at the phase shift of negative 1/4. So if I plug that in, I'd have negative 2 sine of pi times negative 1/4 plus 1/4 minus 3. Okay, that whole thing would give you 0. So you'd have negative 2 sine 0 minus 3. Sine of 0 is 0. So you'd have negative 2 times 0 minus 3 is negative 3. So if you're not sure about where that point is, just plug it in and see what happens. So that's going to phase shift there. The y value gets multiplied by negative 2 and then subtracted 3. So that point right there, that very first point, is going to go there. Okay, so we got that. Your very first point on your graph should be at negative 1/4. Negative 3. I'm going to kind of write down these points as we go. All right. So that would take care of the next one. And then the next point would fall here. All right. And what's happening, remember, is a sine, the next place a sine goes is to its height of 1. Okay. So I just kind of think like this. I say negative 2 times 1 minus 3. What I'm going to end up doing is just taking the y value 0, 1, 0, negative 1, 0, and translating it this way. So that would be negative 2 minus 3, so that's negative 5. So at your next point, which would be positive 1/4, your graph would be down to negative 5. See, there was a reflection in this problem too. So we would go over here and then down 5. So that's where that second point would go now. Okay, all right. The third key point is here. So again, what you're used to is on the sine. The sine has a y value of 0, then the max, then back to 0. So if you go back here, you're just going to do negative 2 times 0 minus 3 again, so that's negative 3. So the point here, that third point, is there. So as we put this together, your graph would be going like that. The fourth key point has a y value of negative 1. So we say negative 2 times negative 1 minus 3. That's 2 minus 3, so that's negative 1. So when we get to this next fourth key point, we're down at negative 1 now. Okay, and then from there you can pretty well predict the next point will be down at negative 3, so you got it. Okay, so that could have been a little tricky for some of you, particularly with that phase shift being not on an increment. Okay, I try to avoid that because when you do that, you have to kind of subdivide it. But it's pretty easy to work with negative 1/4. So that's it. Okay. Now what I would do there is, my thought process on this would just be this. It's not a bad idea to check your points on these things. And I'd probably check a couple of these to make sure they're right. But in reality, all you do is you're looking at these y values. And again, you're doing this. You're just doing negative 2 times 0 minus 3. That gave us negative 3. That's the first point. Then we did negative 2 times 1 minus 3. That gave negative 5 and so forth. Okay, so that's how you get those final points. Now what you should have done on your graph is asymptotes occur at these midpoints. Okay, so we're going to go ahead and just sketch in the vertical asymptotes. So one of them will go through negative 1/4. Another one will go through positive 1/4. Well, no, not that. You got to go through a midpoint. So the next one goes through 3/4 actually. Okay. So I'll take that one through 3/4. Okay, and then the next one will go through here. And then we got it. Okay, then I'll talk about how you probably use the formula on this one. So you've got that. And then what we'll do is we'll just sketch it. So this one's going to go like this. That shape goes down. This shape right here goes up. So you did have a reflection on this one. So it goes like that. Okay, now here, this is what I would do. I just use this formula. So x equals the first asymptote. And it doesn't matter which one you use. I like to use the first positive one, or you can even use this one if you want to. I don't really think it matters that much. So let's just use negative 1/2, that's the first, hold on, negative 1/4, that's where our first asymptote was. And then plus half the period. The period on this one was, what was our period again? I think it was 2. Yeah, the period's 2, so it'd be half of 2. And then times k, and then k would be an integer. Okay, you could go like that. Now, if you did the first positive asymptote, this is actually 1/4, 2/4, 3/4. You could also say x equals 3/4 plus 1/2 times 2k, with k being an integer. Okay, so if you did it this way, you would have y equals, and I don't care which one you write, these just cross out, so you would get y equals 3/4 plus k, where k is an integer. Okay, so notice on this that our first asymptote was at negative 1/4. If you add k to it, which k would be an integer, so like if you added half the period is 1. Notice if you did this, you'd have negative 1/4 plus 4/4, so 3/4. Okay, and see, that would give you that asymptote there. So you can check your asymptotes that way. So that's what I would recommend on that problem, is to do that. Okay, now since this was a fairly complex problem, I think, and it may have been a little bit more challenging for some of you, I would say that let's just check a couple of points to make sure. Okay, so you don't need to write this on here. If you're confident in what you're doing, you don't need to necessarily do this. But I'm just going to say our first point is x equals negative 1/4. And you can check either your sine or your cosecant, because that doesn't really matter. Let's just check the sine. So let's do y equals negative 2 sine. Our factored form is pi times x plus 1/4 minus 3. Just plug this in. See, this first point's easy to check. So you'd have negative 2 sine of 0 minus 3. Work out the details on that, you get negative 3. Okay, I would move on to the next point. The next point is 1/2 or 1/4, so let's check 1/4. So if you do that, you would have y equals negative 2 sine pi times 1/4 plus 1/4 minus 3. So that would be negative 2 sine pi times 2/4 minus 3. I got kind of an extra dangling parenthesis there I don't need. So actually, see, this is negative 2 sine of pi over 2 minus 3. The sine of pi over 2 is 1. Work out the arithmetic, you get negative 5. That's what we thought we'd get. Okay, that's it. That's not hard to check. So we know we're pretty much on the right track. Okay, well, that'll close that off, and hopefully that helps you. The key to doing these is to do the sine and cosine. If you can do that okay, you're fine. Asymptotes, look for a pattern. If you're having trouble with that, just use the formula I gave you. It should be fine. Okay? All right. Good luck, students.